Hi, everyone, and welcome back. So today we're going to pick up where we left off yesterday in our discussion on using the distributive method to multiply polynomials together. So yesterday we took a look at being able to multiply a monomial times a group or times a polynomial, and then how we do it when we take a binomial times another polynomial of really any kind of size. Today we're going to quickly recap that, do a couple more practice problems with it, make sure that you guys are strong with that skill, and then move on and look at big polynomials, how I multiply two trinomials together using the distributive property. So before we get into the examples, again, just want to remind everybody how this process works. Again, you are watching the video to get your notes. Remember, this is not a TV show, so don't just watch it and like you're watching something on Netflix. You're watching and following along and copying down the examples in your notes, whether that's on the PDF copy in Kami or on your own paper at home. Either way is fine. But you guys need to be taking notes so that you can submit pictures of your notes or a copy of your Kami notes after you're finished watching the video. So again, don't be a spectator, be a participant, be engaged while you are watching the video. All right, so again, recall from yesterday, we learned how to multiply polynomials together using the distributive property. Again, remember the distributive property is just when I have something on the outside of parentheses and multiple pieces inside, whatever they are. And remember, the distributive property says that I'm really taking this term or whatever it is on the outside. It could be a group sometimes as well, but we're taking something and sending it into every piece or every term on the inside of those parentheses. So let's try one. So first problem here, I've got one term, a monomial multiplied by a trinomial. So 3 terms inside. So that means I'm going to have to distribute 3 times. So however many pieces there are that you have to distribute into, that's what dictates how many times I have to distribute. So again, whether you write it out long ways and actually show what it is that we're multiplying together each time, you guys can do this if you want to, or if you want to just do this part in your head, that's fine as well. But this is really the math that we're doing. We're taking 4x squared times the first term, plus 4x squared times the second, plus 4x squared times the third, and then whatever the result is, we'll simplify it if need be. So remember, our variables we multiply together, and if they have the same base, we're adding their exponents. So this will become 4x to the 5th. If we have a term where or 2 factors being multiplied, then each have their own coefficient, then we multiply those together, then the variables. So remember that x without an exponent is really raised to the first power, so we have x cubed. And then the last guy, if there are no variables, then we just take care of the coefficients, so that's just negative 16x squared. So that is our final answer. All right, so why don't you guys try this second one? Try it on your own and see what you get. All right, so hopefully if you guys did that correctly, this time I'm going to skip this step of rewriting it the whole way out. We're going to just do that kind of on our own or out loud or in your head as we go. But 3x squared y to the first times 4xy. When we send that in, 3 times 4 is 12. X squared times x to the first is x cubed. Y to the first times y to the first. Again, we're adding those exponents when we multiply variables with the same base. Second term, 3 times negative 5 gives me negative 15. X squared times x squared turns into x to the 4th. Y to the first times y to the second turns into y cubed. So that's our second term. And then the last guy, 3 times 8 gives me 24. This time there is no x factor in this last term for us to multiply x squared by. So that just means that factor is not going to change. There's still an x squared though. And remember, when we've got different kinds of variables in one term, we like to keep them in alphabetical order. So I'm going to go ahead and put the x squared there first. And now we'll do y to the first times y cubed. So that gives me y to the 4th. So if we did that correctly, that's what you guys should have gotten. All right, now for the next two, now instead of having a monomial on the outside being sent into a group, now we've got 2 groups being multiplied together. So remember our plan of attack for these. The first group we are going to break into pieces and basically just do a repeated distributive property like we just did for these first 2. So I'm going to split the first group into its terms. So in this case, there are two terms, and I'm going to take x and distribute that to the group. So I am going to write that out. So it would be x times whatever this second group is. Then we'll take the second term, -5, and distribute it to this group as well. So we do like to rewrite this and show that we're taking each term of the first group and multiplying it by the entire second group, whatever that second group is. And now we just have two of these kinds of problems that we did earlier, and we'll just carry out the distributive property. So x will be sent into both terms here, and then -5 sent into both terms there. When we're finished, remember, we always want to be looking for like terms that we can combine. But x times x gives me x squared. X times 3 gives me 3x. So that's the distributive property for the first set. And then for the second one, -5 times x is just -5x. -5 times 3 is -15. So by the end, when we're finished, again, after that's all the multiplication done, we're done with the distributive property. Now we just have to go through and look for like terms. Remember, like terms mean same variable factors with the exact same exponents. So even though there are multiple terms here with x as a factor, x squared, that's the only factor, or excuse me, the only term where x is raised to the second power. But these two terms have an x raised to the first power, so they're like each other. So when we combine these, 3 of those minus 5 of those leaves us with -2x. Remember that when we're adding like terms, it's only the coefficient part that changes. The variable does not change, nor its exponent. All right, now for the last one, here we've got a binomial, 2 terms, times a trinomial, but that doesn't change this process. We're still going to take the first group and break it into its pieces, and we will take 2x times this whole group. So yes, this method does require a little bit of writing, but that's better than trying to do it all in your head and making a mistake. So 2x times that whole second group minus, now we'll take the second term, -3, and send it to that whole group. So that one's set up for you guys. So why don't you try and finish that one on your own and then check back in and see how you did. All right, so now we are ready to go. Now we'll distribute. So 2x is getting sent to all three, and then -3 is getting sent to all three as well. And then again, we'll look for like terms. So I've got 2x to the first times x cubed. That'll give me 2x to the fourth. Then 2 times 2 gives me 4. X to the first, x times x squared gives me x cubed. And then 2x times -x will give me -2x squared. So that's it from the first set of distributive properties. Then for the second distribution, -3 is going into all this. So if I'm only sending a constant in, then that means only the coefficients can change. So I don't have to think or worry about changing any of these variables. So it's just the coefficients that will change now. So this becomes -3x cubed minus 6x squared, and then -3 times -1. Remember, there's really a -1 out in front of there. Turns into +3x. Now we've got some like terms to look out for. So 4x cubed, there's another x cubed term right here. -2x squared, we've got another x squared term right there. So we're going to add up our like terms now. So we've got 2x to the fourth. Then remember, we want to always keep our answer in standard form. So our next highest degree would be the x cubed term. So 4 of those minus 3 would give me plus x cubed. And then our x squared, so -2 minus 6 gives me -8x squared. And then the linear term, 3x, doesn't have anything to combine with, so it just stays 3x. And that is our final answer. All right, guys, now that we've reviewed our stuff from yesterday, now we're going to take a look at the new kind of problem. But one thing I want you to keep in mind while we go over these is the rules are not changing. Yes, we're going to be working with bigger problems, but all that means is we have more steps. They're going to be just like the steps we took before. There's just going to be more of them. So this first one, we've got x squared plus 3x minus 2 times x squared plus 6x minus 2. So the first step is the same as the previous problems. We're going to take our first group and break it up by its terms. So since this is a trinomial times a trinomial, we've got 3 different terms that we're going to have to multiply by this second group. So our first step is going to be writing that out. So now we're just going to go through and distribute. So we're going to take x squared, send it to all 3 terms, and then we will repeat that process for all of these. All right, so let's take care of that. So x squared times x squared will give us x to the 4th plus x squared times 6x to the 1st. Remember, we're just multiplying the variables together and adding those exponents. X squared times a constant, so there's no variables there to change that part, so we would just get minus 2x squared. So we're just going to keep writing out the rest of the result, and then we'll come back through and we will take care of combining our like terms. So 3x to the 1st times x squared, that's 3x cubed. 3x times 6x, remember coefficients get multiplied together, and then the variables, so x to the 1st times x to the 1st is x squared, and then minus 6x. Then we'll send the negative 2 in. So remember, if I'm only distributing a constant, the variable portion or factors don't change. So we get negative 2x squared minus 12x plus 4. Again, there's nothing new that we're doing here. It's just more of the same, more steps. So you can kind of look at this result and compare it to this one up here. It really does look all the same stuff. It's just there's more terms here. So now we go through, same process. We're going to identify all of our like terms. There's only one x to the 4th term, but there are 2 x cubed terms. Then let's look for x squared. So there's one, and here's one as well. And then we'll do triangles for the x's. So we've got a couple of x terms, and then we've got one constant on its own. So again, our final answer, we want to keep it in standard form. So x to the 4th is the highest degree. Then our x cubed, 6 plus 3 gives me 9x cubes. Then our x squared is negative 2 plus 18 is 16. Minus 2 gives me 14x squared. Then our triangle is negative 6x minus 12x gives me negative 18x. And then our constant. All right, let's try another one. So this one, we've got 3x cubed minus 5x squared plus 2 times 4x squared minus 3x plus 1. So for this one, we're going to, again, split that first guy. So let's write that out. All right, so now why don't you guys try and take care of this first distributive property here. So figure out the result of this distribution. If I send that monomial term into all 3 pieces, what are we going to get? So if you do that one correctly, you should end up with 12x to the 5th minus 9x to the 4th plus 3x cubed. Now let's try the second one. Why don't you guys try to take care of the distribution for this second set? We should get negative 20x to the 4th plus 15x cubed minus 5x squared. And then now let's do the last one together. So remember, we're sending a constant in. So that means the variables aren't going to change. So we get 8x squared minus 6x plus 2. And that is all of our multiplication. Now we just have to worry about combining like terms. So why don't you guys see if you can come up with the final answer on your own. After combining our like terms, we end up with 12x to the 5th minus 29x to the 4th plus 18x cubed plus 3x squared minus 6x plus 2. All right, now for our final one. This one, I actually want you guys to try completely on your own. And there we go. If we do it correctly, that is our final answer. 6y to the 4th minus 24y cubed plus 53y squared minus 58y plus 35. All right, guys, so that is it for the distributive property. At this point, you guys have seen every variation in size that we're going to be testing you guys on. So good luck on the practice worksheet for this. Again, go back and use your notes from the last couple days as guides. If you get stuck on a problem, go back to one that you've written down and copied from class or this video and use it to help guide you through the setup and the solving of your own problems. Best of luck.